Okay, so question 2. Toby claims that for any prime number p, p squared plus p plus 1 is also prime. Okay, show by counterexample that Toby is wrong. So we need to consider here, right, a situation where the result then won't come out prime, okay, for a particular value p. But the approach you need to take is to be sort of systematic, okay, have an order. So we'll start at the beginning. The first prime number, of course, will be 2, and we'll check that one, okay. So we'll check them, substitute in p to be 2. So it'll be 2 squared plus 2 plus 1. And if you work that out, okay, that comes to 7. So the resulting sum is 7. Well, of course, that is prime, isn't it? Okay, so Toby is correct, right? There's nothing wrong with what Toby said there. It works when p is 2. Let's check if it works when p is 3, because that's the next prime number. Substitute it in, okay. So if you work that out, well, that's 9 plus 3 is 12 plus 1 is 13. So the result is 13. So the resulting summation here, well, 13 is prime, isn't it? So yeah, he's right there. Let's check the next prime number. Of course, the next prime number is 5. So 5 squared, substituted in, plus 5 plus 1. So work that out there, 25, 30, 31. 31, it's prime, okay? So he's right there. So it's looking good so far for his statement, isn't it? Okay, let's keep going, okay? Because obviously the statement's wrong. Again, we've got to show here by counterexample that it doesn't work. So let's check 7 then. Okay, that's the next prime number. So 7 squared plus 7 plus 1. So if I work that out, well, 7 squared is 49 plus 7 is 56 plus 1 is 57. 57, that isn't prime. Okay, and the reason why I know it isn't prime, because I know 3 goes into 57, okay, goes into it 19 times. So, you know, when the numbers get larger, you've got to be careful. You know, you might not be so confident with your prime numbers, but just double check that does 3 go into it. Always check 3, because you can miss that one, and 3 does indeed go into 57. So 57 is not prime. Okay, so simple statement like that. So you've shown then, okay. So we've shown by counted example. We found an example that Toby's statement is false, and it is important to finish off, you know, just by doing the table here and finding that there and putting an X here, that's not enough, right? You've got to have a concluding statement. You've got to actually say, look, we've shown by a counter example here, okay, that you know, we've got to address the actual question, okay, and just sort of give a little sort of explanation at the end then as to why Toby is false, because we've found the counter example and we've found a situation where it doesn't work, and we've done what they've asked for.